Hi students, welcome to the video. Okay, today I am solving Keam 2019 question from the chapter Permutations and Combinations. So in that year, 7 questions were asked. Okay, let us see the questions. First question, the sum of all proper divisors of 9,900. So for solving this question, we should know a result. Okay, suppose n is a natural number. Okay, you express n as product of prime factors with powers a raised to alpha into b raised to beta into c raised to gamma into d raised to delta, etc. In this form, if you write, A, B, C, D are distinct primes. Alpha, beta, gamma, delta are natural numbers. Okay, A, comma, B, comma, C, comma, D. Distinct primes. Distinct primes. Then alpha, comma, beta, comma, gamma, comma, delta. They belong to set of natural numbers. Then sum of divisors is equal to a raised to alpha plus 1 minus 1 divided by a minus 1 into b raised to beta plus 1 minus 1 divided by b minus 1 into c raised to gamma plus 1 minus 1 divided by c minus 1 into d to the power delta plus 1 minus 1 divided by e minus 1, etc. So this is the result. This you should remember. So n is equal to, here it is, 9,900. Okay. You use prime factorization method. So 9,900. First you divide it by 2. You will be getting 4,950. Again, you divide it by 2. You will be getting 2,475. Now you divide it by 3, you will be getting 825. Again, you can divide it by 3, you will be getting 275. Now you divide it by 5, you will be getting 55. Again, you divide it by 5, you will be getting 11. So this you can write as 2 square into, I will correct it 1 second. Okay, 2 square into 3 square into 5 square into 11 to the power 1. So the powers are 2, 2, 2, and 1. So straight away we can go to the sum of divisors. Sum of divisors is equal to, or formalize a to the power, that is 2 to the power 2 plus 1, that is 3 minus 1 divided by 2 minus 1 into 3 to the power 2 plus 1, again 3 minus 1 divided by 3 minus 1 into 5 to the power, again 2 plus 1, 3 minus 1 divided by 5 minus 1 into 11 to the power, 1 plus 1, 2 minus 1 divided by 11 minus 1. You simplify this. So you will be getting 7 into 26 divided by 2 into 124 by 4. 124 by 4 into 120 divided by 10. So when you simplify, you will be getting 3, 3, 8, 5, 4. When you multiply. Okay, sum of proper devices. Sum of proper devices. What are proper devices of a natural number? Suppose if you are finding out proper divisors of n, from the divisors you exclude n. That means that number you have to exclude. All numbers other than that number, all devices other than that given number. So they are called proper devices. So these are some of all the devices. Here the number 9,900 also is included. So sum of proper devices will be, you subtract what? 9,900. 33852. So I will correct it. 33852 minus 9,900, which is equal to 2395. 2395. 23952 is appearing in option B. So a little bit difficult question. You should know this result, otherwise you will not be able to solve this question. Okay. Keam examination, nowadays such questions are not being asked. So do not concentrate much on these type of questions. Next. Number of 6-digit telephone numbers having at least one of their digits repeat. So we have got the digits. We have got 10 digits. Starting from 0, 1, 2, etc. 9. A telephone number can start with the digit 0. Okay. See, a telephone number always can start with the digit 0 also. So we have to consider 0 also. So 6-digit numbers, at least one of the digits are repeated. 6-digit numbers, at least one digit repeated. So here we are using the method, if at least one is coming, we are subtracting, no digit is repeated from total number of 6-digit numbers. Total, okay? Total 6-digit numbers. Total numbers equal to, so I'm drawing the rectangles, squares in between, 3, 4, 1, 2, 3, 4, 5, 6. So here a digit can occur in 10 different ways, and here in 10 different ways, because digit can be repeated. 0 can occur the first box, etc., 6 times. So total number of different telephone numbers will be 10 into 10 into 10 6 times, which is equal to 10 raised to 6. Now, numbers such that no digit repeated, no digit repeated, that you calculate similarly. So, no digit repeated again, I am drawing a box for each digit. A digit can occur in the first place in 10 ways. Second box, 9 ways. Third box, 8 ways, or otherwise. There are total, we have got 10 digits. Okay, how many ways we can arrange these 10 digits in 6 boxes? Arrangement of 6 digits out of 10 in a row. The formula is 10p6. Therefore, number of numbers where at least one is repeated. It is very easy. Equal to what? Total number of telephone numbers minus number of telephone numbers where no digit is repeated. So in the remaining numbers, at least one digit will be repeated. So that is the method. So total number of telephone numbers is 10 raised to 6 minus at least one no digit is repeated means 10p6. We subtract that. So we are getting the answer, which is given in option B, 10 raised to 6 minus 10p6. Okay. Next question. Number of ways of dividing 7 men and 7 women. 7 men, 7 women. How they are to be divided? Into 7 couples with a man and a woman in each couple. Okay, no problem. One man we are selected. One man we are select from 7 men in 7C1 ways, and now we are selecting one woman from 7 women. Now this is how we are selecting one man and one woman. Okay, plus now how many are remaining? 6 men and 6 women. Similarly, one man from 6 in 6C1 ways and one woman from 6C1 ways, or etc. last 1C1 into 1C1. So you will be getting 7 squared plus 6 squared plus 5 squared plus etc. plus 1 squared. So when you know the formula, n into n plus 1. So n is 7 into n plus 1 is 7 plus 1 8 into 2n plus 1 2 into 7 14 plus 1 15 divided by 6. Our formula n into n plus 1 into 2n plus 1 divided by 6. Sum of squares of first n natural numbers. Okay, this formula we are using. So simplifying this, you will be getting 140. Okay. Next question. In a group of 8 girls, 2 are sisters. So we can consider 6 girls and 2 sisters. How many ways can they sit in a row? Sit in a row. if the sisters do not sit with each other, do not sit together. Okay. Now we can solve this problem, particular problem, in another way. We take total number of arrangements. So total arrangement. Which is equal to 6 plus 2, 8 factorial. 8 factorial, when you simplify, you will be getting 40320. 40320. Now, sisters together. Number of arrangements. Number of arrangements. Now, sisters together, S1, S2. We consider them as a single unit. Now the girls, 6 girls, G1, G2, G3, G4, G5, G6. Now there are 7 units. Sisters together, 1, then 2, 3, 4, 5, 6, 7. These 7 units can be arranged in 7 factorial ways in a row, and sisters amongst themselves can be arranged in 2 factorial or 2 ways. So 7 factorial into 2. These are number of arrangements in which sisters are together. So when you simplify, you will be getting 10080. Now, you are being asked to find out number of arrangements, sisters not together. Sisters not together. Now it is very easy. We have done a similar question previously. Number of arrangements. So method is very simple. So total arrangement is 40320. We subtract 10,0,080 from that. That means the arrangement where sisters are together. So in the remaining case, sisters will not be together. If it not, when you simplify this, you will be getting 30240. Here, calculation will take little more time. Okay. So answer for that question is option A. Now next question. Okay. Results we are using for solving this question. NCR divided by NCR minus. The formula is N minus R plus 1 by R. It is given that this is 45 divided by 10, which is equal to 9 by 2. So we will be getting an equation in N and R. 2N minus 11R plus 2 equal to 0. This is equation 1. Next one, NCR plus 1 divided by NCR. Similar formula. Equal to numerator N minus R. Denominator R plus 1. You must be knowing how we are getting. N minus R we are getting. Denominator superscript minus subscript. And RHS denominator R plus 1 we are getting from the subscript of LH numerator in LHS. NC R plus 1. That R plus 1 I am writing here. And this is equal to, it is given 120 divided by 45. 120 by 45, when you simplify, you will be getting 8 by 3. So second equation we are getting in N and R, which is equal to 3N minus 11R minus 8 is equal to 0. That is equation 4. Solve equation 1 and 2. You are being asked to find out R. So when you solve it, you will be getting R is equal to 2. Okay? Possibility of asking this type of questions. Okay, more than 50%. Total number of 4-digit numbers in such a way that they are in ascending order. So let us allocate numbers. As usual, we call the numbers, we allocate boxes. Okay, A, B, C, D. The numbers let be A, B, C, D. The condition, ascending order. That means A less than B, less than C, less than D. Now, digit 0 will not appear in any of the numbers, correct? Because A cannot be 0. If B is 0, then A should be less than 0, which is impossible, like that. Hence, A, B, C, and D cannot take the value 0. Now we have got digits, 9 digits only. 1, 2, 3, etc. 9. These 9 digits. Select any 4 from this 9. Selection of any 4 from above 9 digits will give only one number in the form A, B, C, D, A less than B, less than C, less than D. Because in ascending order, you will be having only one number. Smaller number first, then the second number which is greater than that, etc., etc. So one selection, one number. Therefore, total number of numbers. Therefore, total numbers is equal to total number of selections. So 9 digits we are giving. How many selection of 4 digits from here? 9C4. So total number of numbers will be is equal to total number of selections of 4 digits from 9. How many selections are there? 9C4. So 9C4 is appearing in option A. It's a good question. Okay. And the 7th question. It's a good question. So all the questions are quite tough in that year. X is equal to, it is given 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial plus etc. plus 100 factorial. Okay, so this is equal to 1 factorial is 1, 2 factorial is 2, 3 factorial 6, 4 factorial 24, 5 factorial 120, 6 factorial 720 plus etc. plus 100 factorial. Now, when we consider the numbers up to or beyond 120, okay, That means all these numbers. Here 240 is a common factor. So 240 is a common factor for all the numbers coming including 720 and after 720. So we can write it as 420K. Okay. So when you add the remaining numbers, what are you getting? You will be getting 153 plus, and the last group of numbers, we are getting 240K. So this we can write as 240 into 240 is divisor into K is quotient plus remainder. The result, dividend is equal to divisor into quotient plus remainder. So definitely remainder will be 153. The last number is the remainder when this sum x is divided by 240. Therefore, 153 is the remainder. So such questions are very important. Okay. Thank you.